we're going to work several problems here solving exponential and logarithm equations using logarithms. So this first one is an exponential equation because it has our variable right up here in the x location. Or, pardon me, the variable is in the exponent location. So we need to determine, should we work it like we did in the last unit where we solved it using just our exponent rules, or should we apply what we've learned in this unit and use logarithms? Well, the key is to look at the base, and you see the base right there is 4, and we have a base of 5 over here. So we ask ourselves, if we're working and solving this just with our exponent rules, we need to be able to set like bases. Well, a base of 4, a base of 5, we really can't set like bases. So that's when we need to work in these logarithms here and use that strategy. So that's what we're going to do. And we've discussed that if this is equal to this, that means I can take the logarithm of this side and set it equal to the logarithm of this side and not break any algebraic rules. So that's what we're going to do. So log of 4 to the x power is equal to log of 5. This is an implied log base 10. We don't have to write it. We talked about that, but that's what it is. Okay, so now we can start applying our exponent rules, and I've gone ahead and I've got those over here so that we can work with them. And the biggest one when you're solving these equations, for the most part, the most important one is this one right here, because this allows you to take an exponent and move it in front as a multiplier. And what that does for us is it allows us to take this variable exponent and move it to the front and unlock this variable from that exponent location. So in the next step, that's what we're going to do. We have x log of 4 is equal to log of 5. And now we just divide by log 4 on both sides, divide by log 4 on both sides, and finally we get x equals log base 5 over, log of 5 over log of 4. And this is some decimal value. We don't have a calculator in this unit, so we'll leave it like this. So we've solved that one. Let's look at the second one from your homework. All right, here we are with the second problem from your homework. So we have an exponential equation. Why an exponential equation? Because it's an equation with an exponent variable up here in this spot. So we want to ask ourselves, can we establish a like base on both sides? If so, then we can use our exponent rules to solve it. And in this case we can, because 16 is the same thing as 2 to the 4th, and that's equal to 2 to the 3x plus 2. So now this looks just like the last unit where we have established the process that we've used for solving using our exponent rules. We have a like base on both sides, base 2 on both sides, and our process said that we can now set those exponents equal to one another and solve, so that's what we're going to do. So 4 equals 3x plus 2. Subtract 2 here. We get 2 equals 3x. We divide 3, and we finally get x equals 2/3, and that's it. We're done with this one. So there was no need to use logarithms in this case. We could have, but there was no need because we could set like bases. That's the question that you need to ask yourself as to whether you need to use logarithms or not. Can you establish like bases? If so, go ahead and solve it just like we did here. Get it set up that way. If you can't get like bases, then you must use your take the logarithm of both sides and apply your logarithm theorems and properties to solve it. All right, let's look at the next one. All right, number 3 here, we've got a base of 4/5 over here on this side. We've got a base of 11 over here on this side. So we ask ourselves, can we set like bases? No, not really. 4/5 and 11, we're not going to be able to set like bases there. So we're going to need to take the logarithm of both sides. So we would get log of 4/5 to the x power is equal to the logarithm of 11 to the x minus 1 power. So as discussed, the most important theorem for solving exponential equations with logarithms is this one right here, because this allows us to take the exponent and move it to the front of the logarithm using this theorem, and that will unlock these exponents, these variable exponents here. So we'll do that, and we get x log of 4/5 equals the x minus 1 quantity times log 11 over here on this side. Remember, you have to take the whole quantity here, the x minus 1 quantity. So then we've discussed how log 11 is simply a quantity, so we can actually distribute that in here. And once we do that, the left side stays the same. X log 4/5 is equal to x log 11 minus log 11. We just distributed the log 11 in. Log 11 times x is x log 11. Log 11 times -1 is negative log 11. Our whole goal here is to get x by itself, and we've had a similar problem when we worked with our examples earlier. And we want to get the x's by themselves, so I'm going to bring this x term over here, and once I do that, I'm just going to subtract it. I'm going to do the shorthand version of this so we can save time. So x log 4/5 subtract x log 11 is equal to negative log 11. So all I did is I subtracted this, and which moved it over here to this side. So now notice we have our terms with x's in them all together on this side. So the next thing I'm going to do is factor out this x. So I factor out the x on that side, and I'm left with log 4/5 subtract log 11. And that is equal to the negative log 11 from this side here. So if we distribute that back in here and here, we will end with where we started, and we know we factored it out correctly. And now all we have to do to isolate this x is divide by this whole chunk. So we'll do that. So log 4/5, we're dividing by this whole chunk here over here, which means we have to do it over here. Log 4/5 minus log 11, and that will cause this to cancel, and we're left with x equals this whole quantity, and negative log 11 over log 4/5 minus log 11, and that is our answer. You could put this in a calculator and get some decimal value. We will not be doing that because we're not using a calculator in this unit, so we will leave it just like this, and number 3 is solved. Alright, this is number 7 from your homework. So we have 75 over the quantity e to the negative x power plus 2 is equal to 125. So I'm just going to rearrange this a little bit and basically just cross multiply here. So I get 75 equals 125 times the quantity e to the negative x plus 2. The whole goal is to isolate this x variable here, and now I'm going to divide by the 125 there, and I'm left with 75 over 125 is actually 3/5. 25 goes into 75 3 times, 25 goes into 125 5 times, so that reduces to 3/5 equals e to the negative x plus 2. Now I'm going to subtract this 2 from both sides. Subtract 2. 2 is the same thing as 10/5. I'm going to mark that out. Make it 10/5. Negative 10/5 here. So 10 divided by 5 is 2. So it's still 10/5. So I'm subtracting 10/5 from 3/5. And now up here I get negative 7/5 is equal to e to the negative x. Okay, so now I ask myself, can I apply like bases here? No, I can't. I have a base of the e here, and I would technically this negative 7/5 is raised to the first power, so I'm not going to be able to solve it using my exponent rule. So I'm going to take the logarithm of both sides. We haven't done this yet, but we've been taking the log base 10 of both sides like this. There's an implied 10 here. Well, you can also take the natural logarithm of both sides, and we're working with a base of e, which is the natural logarithm is base of e, so we'll just take the natural logarithm of both sides. Again, I could take the regular logarithm of both sides, it doesn't matter, But just to show you that you can use different bases for the logarithms when you take the log of both sides, we'll do that. So I'm going to take the natural logarithm of both sides. So the natural logarithm of negative 7/5 is equal to the natural logarithm of e to the negative x. And now I apply the most important theorem for, in my opinion, for solving these equations. And I'll move this negative x to the front here, apply that theorem. So I get ln of negative 7/5 is equal to negative x times the natural logarithm of e. So now that I have done that, all I have to do is I want to isolate this x, so I can divide by the natural logarithm of e on both sides. And I end with negative x equals natural logarithm of negative 7/5 over the natural logarithm of e. So if you understand what the natural logarithm of e is, I'll write it this way: ln of e, or log base e, is the same thing as the logarithm of e. So what does that equal? Well, e to what power equals e? Well, e to the first power equals e. So this whole thing right here is actually just 1. So I can cross that out and simplify this a little bit. So now I have negative x is equal to the natural logarithm of negative 7/5. I could divide by negative 1 here, like this, and get x equals negative ln of negative 7/5. Well, here's the problem. I'm having to take, to solve for x, I'm having to take the logarithm of a negative number, so that means there is no solution for x. So we stop there and we say no solution. No solution. There we go. So that's it for this video. I am going to make probably one more video here and work some additional problems with these as well. So look for another video for that.